A rational expression has a polynomial in the numerator and the denominator. With rational expressions, you can add, you can subtract, you can multiply, or you could divide. It's important to keep in mind that when I'm dealing with fractions and I'm adding or subtracting, I need a common denominator. When I multiply or divide, I do not need a common denominator. Another part of rational expressions that you can talk about is a restriction. Keep in mind that you can never divide by 0. So a value which gives you a 0 in the denominator means you now have a restriction. Let's look at the first problem. I am asking you to subtract. Therefore, to subtract, you must have a common denominator. I do have a common denominator. So I do just like you would do with any other fraction. You just subtract the numerators. So you have x squared minus y squared divided by x plus y. However, we're not finished because I need to actually simplify as much as I can. You always want to reduce a fraction. So to simplify, I need to factor the numerator. Since it's a difference of squares, it becomes x minus y, x plus y. The denominator stays x plus y. Now I need to reduce. The x plus y in the numerator and the x plus y in the denominator reduce, so my final answer is just x minus y. Let's look at number 2. Again, I'm asking you to add. In this case, they do not have a common denominator. So I need to factor so I can figure out what my common denominator will be. This factors as x plus 4, x minus 1. This one's a difference of perfect squares, so it factors as x minus 1, x plus 1. Okay? So now if I'm looking at these, I know that my common denominator is going to have an x minus 1, an x plus 4, and an x plus 1. However, look again. In this second fraction, I have an x plus 1 and an x plus 1. Those can reduce. When I reduce, I now have x over x plus 4 multiplied by x minus 1 plus a 1 over x minus 1. So my common denominator is going to be x minus 1 and x plus 4. I need both parts. I don't need to multiply the first fraction by anything. It already has the common denominator. But I need to multiply the second fraction by x plus 4. And you need to multiply the numerator and the denominator. Now I rewrite it. Now that I have a common denominator, I just add the numerators, so I have 2x plus 4 over x minus 1, x plus 4. Keep in mind I always want to reduce fractions if I can, so I need to factor the numerator, see if anything will reduce, and nothing will. So this is my final answer. Now let's talk about the restrictions. What are the values that x cannot be? You need to go back to your original problem and look at what is in the denominator. What values of x will make the denominator 0? Well, I've got negative 4 will make this 0, which will make that denominator 0. X could be a positive 1, which would make the denominator 0 here. Or x could be negative 1, which would make this denominator 0. So I have 3 restrictions on the domain. Okay, let's try a new problem. Now I have 3 over x minus 5 over x plus 3. So I need a common denominator. In this case, the denominators don't factor. They're already factored for you. So my common denominator, I need each piece. I need an x, and I need an x plus 3. I can't just add 3 to the first fraction and call it a common denominator. You have to multiply. So I multiply the first fraction by x plus 3, in the numerator and the denominator. Multiply my second fraction by x in the numerator and the denominator. And I have 3x plus 9 minus 5x all over x times x plus 3. Combine like terms. Negative 2x plus 9, x plus 3. Notice that I'm not distributing the denominator because I know at the end I need to factor to see if something can reduce. I can only reduce things if they're being multiplied. So I want to leave it factored in the denominator so that I can potentially reduce. In the numerator, you want to distribute. When you distribute, you can combine like terms. You can combine the fractions. So there's my final answer. What are the restrictions here? In this case, x cannot equal 0 or negative 3. Okay, let's try a problem like this. Now I've got two operations going on. I have to subtract and I have to divide. So you need to know which one comes first. Order of operations tells us parentheses come before division. So I need to subtract these first. Need a common denominator. Common denominator will be 3y. So 12 over 3y minus 2 over 3y becomes 10 over 3y. Now I need to divide, and dividing is the same as multiplying by the reciprocal. So I'm going to multiply by the reciprocal. Now I need to reduce. I can reduce this 3 and this 6. I can reduce the y with the y. Now I multiply the numerators to get 20 over 3y plus 2. What are my restrictions here? Y could not be 0 because of right here. Also 0 because of right there. And also 0 here. There's another restriction though. Here's another denominator which cannot equal 0. So I need to put that in. So negative 2/3 is the restriction there. Okay, let's try a division problem. So in order to reduce these, I need to factor. So what's the greatest common factor from this part? An x. 2x minus 1. In the denominator, 6x is the GCF. X plus 2. Division, again, means multiply by the reciprocal. So I'm going to multiply by 4x times x plus 2. Denominator would be 2x minus 1. Now I reduce. X plus 2, 2x minus 1, and 2x minus 1. X and x. 4 and 6 becomes 2/3. 2x over 3 is my final answer. I could find the restrictions, but I only need to find the restrictions if it asks. In this problem, I'm just going to simplify. Okay, last problem. Again, let's just simplify. So I've got 16x squared, which doesn't factor. X squared minus 4 is a difference of perfect squares, so that factors. Multiplied by 4x squared minus 4x minus 3, so I'm going to do the factoring over here. 4 times negative 3 is negative 12. Factors that multiply to negative 12 and add up to negative 4 would be negative 6, positive 2. 4x squared minus 6x plus 2x minus 3, GCF. So my factors are 2x minus 3, 2x plus 1. The denominator, I have greatest common factor of 4. Factor that. And now I have a difference of perfect squares. 2x minus 1, 2x plus 1. This one I'm multiplying by the reciprocal. 1 minus 4x squared is a difference of perfect squares. Again. The denominator has a GCF of 3x. 2x plus 3 is left over. Now I'm reducing as much as I can. I see a 1 plus 2x. 1 plus 2x. It's an x. An x squared makes an x over there. And that's all that I have so far. Okay, what about this 2x minus 1 and 1 minus 2x? Those are close. So let's rewrite this. I were to factor out a negative 1 from 1 minus 2x, I would have a negative 1 plus 2x. Now they're the same. So now I can reduce those. I can also reduce the 4 and the 16. So this is my final answer. Don't forget the numerator has that negative 1. So I'm going to multiply negative 1 times 4 right there. And that's it.